William S. Knudsen stood in a Pentagon conference room in May 1940, facing a table of skeptical Army generals who thought he'd lost his mind. This 61-year-old Danish immigrant who'd climbed from bicycle mechanic to president of General Motors had just made a promise that sounded like pure fantasy. He told them he could build tanks the same way Detroit built Chevrolets, Fords, and Chryslers, with thousands of them rolling off assembly lines so fast the numbers would seem impossible to fathom. The generals exchanged glances. One actually laughed. America's entire tank production in 1940 had limped to just 331 units for the whole year. Knudsen was proposing hundreds per month from car factories run by civilians who'd never seen a military vehicle. But Knudsen wasn't bluffing. He'd spent 30 years mastering something the military had never considered applying to warfare: the Ford production philosophy. While European nations at that time built tanks like medieval craftsmen, forging swords one meticulous unit at a time, Knudsen saw them as just another consumer product waiting to be mass-produced. The Model T had taught him that complexity dies when you break it into simple, repeatable steps. A tank wasn't a mystical weapon. It was steel rivets, an engine, and tracks. If you could build 15,000 cars a day across America, you could build 500 tanks. The math was simple. The execution would be hell. The Army's Ordnance Department hated everything about this idea. Their engineers had spent decades perfecting tanks through small-batch custom manufacturing. Each M2 medium tank required skilled machinists working from complex blueprints, hand-fitting components, treating every vehicle as a unique creation. Production crawled because craftsmanship demanded time. Knudsen's proposal insulted that entire philosophy. He wanted to distill the process, break it into idiot-proof steps, hire anybody off the street, and crank out identical machines to the ordnance officers. This wasn't efficiency. It was barbarism. One colonel called it the automotive industry's arrogance, thinking war is just another product line. Knudsen had heard worse. Back in 1913, Henry Ford's competitors said the same thing about assembly lines for cars. Then Ford buried them. Now Knudsen was betting America's survival on applying that same ruthless industrial logic to armor. He'd already done the preliminary calculations. Detroit had 4.5 million square feet of idle factory space after the Depression. The machine tools existed. The workforce was unemployed and desperate. The only missing ingredient was permission and a tank designed simple enough to mass produce. When Britain's new M3 medium specifications arrived in July 1940, Knudsen saw his opportunity. The Army wanted 1,000 of them. He quietly told his engineers to prepare for 10,000. Roosevelt gave him the authority on May 28, 1940, creating the National Defense Advisory Commission with Knudsen as Director of Industrial Production. No salary, no official military rank, just unlimited power to retool American manufacturing for war. Knudsen walked out of that White House meeting and immediately called Detroit. Chrysler's tank arsenal would break ground within 90 days. He gave them a target that made his own engineers nervous: 1 tank every hour, within 2 years. It wasn't a goal. It was a demand. Either American industry would achieve the impossible, or the Nazis would be unstoppable. There was no middle ground. The race had started, and Knudsen had just promised to win it, using civilians who didn't even know what a tank looked like. Yet. Pearl Harbor changed everything overnight. On December 8, 1941, Knudsen's theoretical production plans became America's only lifeline. The phone lines at the War Production Board burned hot as factory managers across Michigan, Ohio, and Pennsylvania received identical orders: stop making whatever you're making and start building tanks now. The Cadillac plant in Detroit that had been stamping luxury car fenders was suddenly expected to forge tank turrets. Fisher Body, famous for sleek automobile curves, got blueprints for armored hulls. Nobody had done this before. There was no manual titled "How to Convert Your Buick Factory into an Armory." In 3 weeks, they were inventing the process. While German panzers rolled across North Africa and Soviet T-34s burned in Ukrainian fields, the chaos at the Chrysler tank arsenal in Warren, MI, during January 1942 looked less like precision manufacturing and more like controlled panic. Workers showed up to buildings where concrete was still curing on the factory floor. The assembly line existed only as chalk marks on bare ground. Crates of tank components arrived before anyone knew where to store them, so they piled up in parking lots under tarps. Forklifts navigated between construction crews still installing overhead cranes. The first M3 medium tanks assembled there in April 1942 were basically hand-built, taking 2 weeks per vehicle, slower than the craftsman approach Knudsen had promised to replace. Engineers stood on the factory floor, literally rewriting blueprints in real time as they discovered tolerances that worked in prototypes but failed at scale. Training became the nightmare nobody had anticipated. You could retool a building in months, but how do you transform a laid-off restaurant cook into someone who could weld armor plate? That had to stop armor-piercing rounds? The traditional approach, apprenticeships lasting years, was impossible. Knudsen's training director, a former Ford efficiency expert named Carl Bailey, created a radical solution. They broke welding into exactly 17 specific techniques needed for tank production, nothing more. A recruit didn't learn to be a master welder. They learned to make one perfect weld in one specific location over and over again, 10 hours a day. It was the assembly line philosophy applied to human beings. Critics called it dehumanizing. Bailey called it the only way to build 1,000 tanks a month, with workers who'd never held a welding torch 3 weeks earlier. The material bottlenecks nearly strangled production before it started. Armor plate was the critical constraint. Only a handful of American steel mills had the rolling capacity to produce the thick, hardened steel required for tank hulls, and they were already backlogged supplying shipyards. In February 1942, Knudsen personally visited Bethlehem Steel's plant in Pennsylvania and made an offer the CEO couldn't refuse. Government financing for a new plate mill that would triple their output, but only if they delivered the first run to Detroit within 90 days. They did it in '87. Meanwhile, the shortage forced engineers to get creative. The M3's riveted construction, which traditionalists had insisted on, became a liability. Rivets took time and required pre-drilled holes with precision tolerances. Welding was faster but required higher skill. The compromise? Teach welding faster, simplify the joint designs, and accept a 15% reject rate that quality control would catch. By March 1942, the Chrysler line finally started hitting rhythm, producing 4 M3s per day. It was nowhere near Knudsen's vision, but it was movement. Then the Army changed everything again. They wanted the new M4 Sherman instead, a better design, but completely different production requirements. Every jig, every tool, every training program built around the M3 became instantly obsolete. Knudsen didn't flinch. He'd been expecting this. War doesn't wait for perfect conditions. You adapt or you lose. The retooling began immediately, even as M3s were still rolling off the line. 2 assembly lines, 2 tank types, 1 factory, 0 margin for error. Welcome to industrial warfare, American style. The M4 Sherman that arrived on blueprint paper in August 1941 was a 30-ton mechanical nightmare for mass production. It contained roughly 8,000 individual parts, not counting the 50,000 rivets some variants used. The Wright R-975 radial aircraft engine alone had 847 components. The transmission required 23 precision gears machined to tolerances of 1/1000th of an inch. The vertical volute spring suspension system used 48 bogie wheels per tank, each needing individual rubber cushioning. Army Ordnance had designed it for battlefield superiority, not factory efficiency. Knudsen's engineers took one look at the specs and knew their job was surgical. Dissect this beast, simplify everything possible, and make it so straightforward that someone's grandmother could assemble a section without screwing it up. The breakthrough came from AGM engineer named John WWII, who'd spent 20 years designing Cadillac transmissions. He gathered the team in September 1941 and drew a radical concept on a blackboard: treat the Sherman not as one integrated machine, but as 7 major sub-assemblies that could be built simultaneously in different locations, then married together in final assembly. Hull, turret, engine, transmission, suspension, electrical armament. Each sub-assembly would have its own dedicated line feeding into the main artery. The hull alone got broken into 22 separate stations, each performing one specific task. Station 7 did nothing but install the transmission mounting brackets. Station 14 existed solely to weld the bow gunner's hatch. This wasn't tank building anymore. It was choreographed industrial dance, with 300 workers each performing their individual moves in perfect sequence. Ford's River Rouge plant took the philosophy even further. With their version, they vertically integrated everything. Knudsen had watched Henry Ford build a factory where iron ore entered one end and finished cars drove out the other. Now they'd apply that to armor. Raw steel arrived at the Rouge plants. Blast furnaces got rolled into armor plate in their own mill, cut to size in their stamping facility, welded into hulls, and Building B mated with engines from Building C, and completed tanks rolled out the opposite end 48 hours after the steel had been molten. Every Sherman component, except the main gun, was manufactured on site. When a design flaw appeared, they could fix it in the steel mill and see the correction on finished tanks within 2 days instead of waiting weeks for outside suppliers. Speed wasn't just about moving fast. It was about eliminating every delay in the chain. The turret presented special problems. Early designs required a massive casting, one single piece of formed steel weighing 3 tons. Only a handful of foundries in America could pour castings that large, and the reject rate was brutal. Nearly 40% of turret castings failed quality inspection because of air pockets or cracking during cooling. Each failure meant remelting tons of steel and a 2-week setback. Pacific Car and Foundry in Seattle solved it by developing a welded turret design using flat plates instead of one complex casting. It was heavier, less elegant, and ordnance officers hated it on principle, but it worked, and more importantly, production yield jumped to 94%. Knudsen approved the change immediately over Army objections. Tanks on battlefield beat perfect tanks on drawing board. That was his only standard. Standardization became religious doctrine when multiple factories started producing Shermans. Chrysler, Fisher, Ford, Federal Machine, Pacific Car, Pressed Steel, Baldwin Locomotive. Each plant initially wanted to make improvements to their design. Chrysler thought their transmission was better. Fisher wanted a different engine. Mount Knudsen shut it down brutally. Every factory would build identical Shermans using identical specifications, identical tooling, identical processes. Parts had to be interchangeable across every tank, regardless of which factory built it. A transmission from Detroit had to drop perfectly into a hull from Chicago. This wasn't about engineering pride, it was about battlefield logistics. When a Sherman threw a track in North Africa, the repair crew didn't have time to check which factory built it before grabbing replacement parts. Standardization meant a tank damaged on Monday could be fighting again on Tuesday. Variety meant death. The workers flooding through factory gates in early 1942 looked nothing like the precision machinists Army brass had envisioned building their tanks. Anna Kowalski had been serving coffee at a Detroit diner 2 weeks before she found herself welding hull plates on the Chrysler line. James Washington, a 58-year-old Alabama sharecropper, had never operated anything more complex than a mule plow. Now he was installing transmission assemblies. Margaret Chen, barely 5 feet tall, climbed into turret compartments to wire electrical systems in spaces engineers had assumed only small men could access. Over 40,000 people worked Sherman production across multiple plants by mid-1942, and roughly 65% had zero manufacturing experience. Knudsen had predicted this. Wars aren't won by waiting for skilled workers to appear. You create them from whoever shows up. The training system Bailey designed was brutally efficient because it abandoned the idea of creating well-rounded craftsmen. On her first day, Anna didn't learn welding theory or metallurgy or proper torch angle for 8 different materials. She learned one weld, the vertical seam, where hull side meets hull bottom on the M4A3 variant. That's it. Her instructor, a former pipeline welder from Texas, spent 4 hours showing her the exact torch distance, precise feed rate, and specific motion pattern. She practiced on scrap metal for another 8 hours until the bead looked identical every single time. By day 3, she was on the production line making that weld for real, dozens per shift. Station 23 became her entire universe. She got so good at that one specific weld that her reject rate dropped to under 2%, better than workers with 10 years of general welding experience. The speed of training created quality control nightmares that nearly derailed everything. In March 1942, a batch of 47 Shermans failed Army acceptance tests because internal welds on the ammunition racks were substandard. They'd crack under sustained firing vibration, potentially detonating the tank's own shells and killing the crew. Inspectors traced the problem to one training class where the instructor, overwhelmed by 200 new recruits, had cut corners on teaching proper penetration depth. Those workers had been making bad welds for 2 weeks before anyone caught it. Every tank they'd touched had to be pulled, disassembled, re-welded, and re-inspected. The delay cost 11 days of production. Knudsen's response wasn't to slow down training, it was to add inspection stations. Every 7th Sherman got completely disassembled by quality control teams who checked every weld, every bolt, every tolerance. Brutal, wasteful, but it caught problems. Before tanks reached battlefields, the factories ran 3 shifts, 24 hours, 7 days a week. The night shift, 11 p.m. to 7 a.m., was the hardest. Workers called it the zombie shift because you never adjusted. Human bodies aren't designed to work when every biological instinct screams for sleep. Productivity dropped 15% on night shifts, and injury rates doubled. Dorothy Martinez, working the turret assembly line at Fisher Body, fell asleep standing up at 3 a.m., and her hand drifted into a moving conveyor belt. She lost 2 fingers. The factory didn't stop. Her station was filled within 20 minutes by a floater worker who'd been trained for exactly this situation. Dorothy was back on a different station 3 weeks later. Because missing fingers didn't disqualify you, only missing hands did. The cold calculus of wartime production meant everybody that could contribute did contribute. The workforce transformed the factories into strange communities. Since many workers had relocated from across America chasing defense jobs, they essentially lived at the plants Chrysler built on-site dormitories housing 3,000 workers. The cafeteria served 15,000 meals per day across all shifts. A barbershop, medical clinic, and even a small post office operated inside the factory complex. Children attended daycare in converted storage buildings while mothers welded armor plate 200 feet away. The line between civilian life and war production dissolved completely. You ate where you worked, slept near where you worked, and your friends were the people who worked your station. When the PA system announced Allied victories in North Africa during lunch breaks, the cheers echoed off steel rafters because everyone understood those were their tanks winning those battles. Every Sherman rolling off the line carried a piece of 40,000 individual stories, most of which would never be told. April 12, 1943, marked the moment Knudsen's impossible promise became reality at the Grand Blanc Tank Arsenal, a sprawling complex covering 113 acres of former Michigan farmland. Sherman No. 1000 rolled off the line at 2:47 p.m., exactly 55 minutes after Sherman 999. The plant had hit the rhythm Knudsen had envisioned 3 years earlier when generals laughed at him. One complete M4A3, Sherman medium tank, fully assembled. Every system tested ready for combat, emerging from final inspection every 55 to 60 minutes, hour after hour, shift after shift. The Germans were producing roughly 500 tanks per month across their entire industrial capacity. Grand Blanc alone was beating that number, and it wasn't the only Sherman factory. Walking the Grand Blanc line during peak production felt like witnessing industrial ballet choreographed by a madman. The main assembly line stretched nearly half a mile. Overhead conveyors carried major components, hulls, turrets, engines, in perfect synchronization. Every 6.5 feet represented 1 minute of production time at the line's start. Raw welded hulls arrived from the fabrication building, still warm from final welds. Station 1 workers had 55 seconds to bolt the transmission mounting frame before the hull moved to Station 2. Nobody rushed. Rushing meant mistakes. Instead, every motion was optimized down to the specific hand used to grab each bolt. The workers moved with the mechanical precision of the machines they were assembling. Because they'd repeated these identical motions 400 times per shift for months, the suspended track assembly system became the line's most recognizable innovation. Traditional tank production required workers to manually lift and position the heavy track sections, brutally hard work that slowed everything down and regularly injured backs. Grand Blanc engineers suspended the tracks from ceiling-mounted cranes that moved in sync with the assembly line. As each Sherman progressed, its tracks descended at the exact moment the suspension bogies were ready. Workers guided them into position, and pneumatic tools drove the connecting pins home in 90 seconds flat. What had taken 45 minutes of heavy labor now took less than 2. That single innovation, replicated across 8 workstations, saved nearly 6 hours per tank. Multiply that by 16 tanks per day. And suddenly, you're producing an extra battalion of armor every week from pure efficiency gains. The engine marriage station was where everything either came together perfectly or fell apart spectacularly. The Continental R975 radial engine, weighing 2,100 pounds, had to mate with the transmission, connect to fuel lines, oil lines, coolant lines, electrical harness, and exhaust, all within a 12-minute window. 4 workers surrounded each tank in a precisely choreographed sequence. Worker 1 dropped the engine using an overhead hoist while Worker 2 guided it onto mounting studs. Worker 3 connected the transmission coupling while Worker 4 simultaneously ran electrical connections. They never spoke. They just used hand signals. The noise level of the hammering, welding, engine testing, metal screeching made conversation impossible anyway. They'd done this exact sequence so many times that verbal communication became unnecessary. Each worker knew what the others would do next through pure muscle memory. Quality control became a religion because speed without reliability meant nothing. Every tank at Grand Blanc underwent the death run, a 3-mile course on the factory grounds featuring mud pits, steep hills, sharp turns, and obstacles designed to stress every system. Engines ran at full throttle. Transmissions shifted through every gear under load. Suspensions absorbed impacts that simulated battlefield conditions. If anything failed, an oil leak, transmission grind, track throw, electrical fault. The Sherman was pulled immediately, the defect traced to its source station, and the worker responsible retrained on the spot. The reject rate hovered around 8%, meaning roughly 1 in 12 tanks failed initial testing. But those 8 failures meant the other 92 reached North Africa, Italy, and eventually Normandy, with systems proven under stress. Nobody wanted their name associated with a tank that failed in combat because training was inadequate. By summer 1943, the combined American Sherman production from all plants hit 2,020 tanks. In July alone, that single month's output exceeded total German tank production for the entire year of 1941. The assembly line concept had done exactly what Knudsen promised. It turned American industrial capacity into an unstoppable flood of armor. Soviet officers visiting Detroit factories stood speechless watching Shermans emerge with metronomic regularity, later reporting to Stalin that American production capability was beyond comprehension. The British, receiving thousands of Shermans through land lease, rebuilt entire armored divisions around American-made tanks because they simply couldn't match the output. The 60-minute Sherman wasn't just manufacturing achievement, it was the moment industrial capacity became a weapon more decisive than any gun. The telegram from North Africa arrived at Knudsen's office on February 18, 1944, and it carried the kind of news that turns assembly lines into graveyards. American tank crews were reporting catastrophic failures when engaging German Panthers and Tigers. Shermans were burning after single hits, their thin armor penetrated easily. Crews incinerated inside what soldiers grimly called Ronsons after the cigarette lighter advertised to light on the first strike. The 75mm main gun couldn't penetrate German frontal armor beyond 500 yards, forcing Shermans to close to near-suicidal ranges. Crews were refusing to board tanks. Some units reported desertion rates climbing. The Army needed solutions yesterday, and shutting down production to redesign wasn't an option. The factories were producing 1,500 Shermans monthly, and Eisenhower needed every single one for the upcoming Normandy invasion. The engineering team at Chrysler faced an impossible equation to fix critical vulnerabilities without stopping the line. Complete redesign was off the table. They had 4 months until D-Day, and tanks already in production had to reach Europe combat-ready. The solution came from battlefield reports themselves. Crews were jerry-rigging their own improvements, welding spare track sections onto hull fronts for extra armor, sandbagging vulnerable ammunition storage areas, even attaching logs and spare wheels as improvised protection. If soldiers were modifying tanks in combat zones with scraps, maybe the factory could systematize those modifications during production. The concept of midstream retrofitting was born, changing the product while it moved down the assembly line without disrupting the flow. The ammunition storage redesign happened first because it was the most lethal flaw. Early Sherman stored 75mm shells vertically along the hull sides, convenient for loaders, but catastrophic when hit. Penetrating rounds would strike ammunition directly, causing instant detonations that blew turrets 30 feet in the air. In March 1944, engineers redesigned the storage to position shells flat on the hull floor, surrounded by water jackets, wet stowage that would absorb heat and suppress fires. Implementing this change mid-production required adding 3 new stations to the assembly line without slowing the overall flow. Station 31A now installed the water jacket systems. Station 31B repositioned ammunition racks. Station 31C tested the water circulation. Tanks entering the line Monday had old storage tanks, leaving Friday had wet stowage. No production gap. Battlefield survival rates for Shermans with wet stowage jumped from 60% crew survival to 85%. The armor problem proved harder because you can't add meaningful protection without adding weight, and weight meant redesigning suspensions, engines, and transmissions. The compromise was applique armor bolt on plates that crews could add based on mission requirements. Fisher Body created standardized kits, frontal hull plates, adding 1 inch of armor, turret cheek plates, even track guards. These kits were manufactured separately and shipped with the tanks, allowing field commanders to configure Shermans for specific roles. Tanks leading assaults got maximum armor. Exploitation units kept weight down for speed. It wasn't elegant, but it worked. More importantly, it worked without redesigning the base Sherman, meaning the 6,000 tanks already in the production pipeline didn't become obsolete overnight. The 76mm gun upgrade created the biggest production headache. The new high-velocity gun could actually take out German heavy tanks, but it required a completely different turret. Larger, heavier, with modified recoil systems, Ordnance wanted all new production shifted to the 76mm variant immediately. Knudsen's team pushed back hard. Retooling turret production across multiple factories would cost 6 weeks of output, roughly 2,000 tanks that wouldn't reach Europe in time for Normandy. The compromise was brutal and practical. Split production. The Chrysler line would continue 75mm Shermans at full speed. The Fisher line would slow by 30% to retool for 76mm variants combined. Output would drop temporarily, but the flow wouldn't stop completely. By June 1944, both versions were being produced simultaneously, giving battlefield commanders options instead of forcing one solution for all situations. The adaptation process revealed something Knudsen had understood from the beginning. Assembly lines weren't rigid mechanical systems. They were living processes that could evolve under pressure. Traditional military procurement would have halted production, demanded perfection, and delivered the ultimate tank 2 years late, the assembly line philosophy said. Keep building, fix problems incrementally, and trust that volume creates opportunities perfection never could. A Sherman with wet storage and plaquette armor wasn't as good as a Panther in one-on-one combat, but 5 Shermans arriving this month beat 1 perfect tank arriving never. The line kept rolling, the modifications kept coming, and most importantly, the tanks kept reaching the soldiers who needed them. That was the only metric that mattered in wartime. Not perfection, but presence. The final production numbers tell a story that German tank designers never wanted to hear. Between February 1942 and July 1945, American factories produced 49,234 Sherman tanks. 49,234. Read that number slowly because it represents the industrial gap that decided armored warfare in World War II. Germany built approximately 6,000 Panthers, their best medium tank, superior to the Sherman in nearly every technical specification. They produced roughly 1,350 Tiger tanks. Feared monsters that could destroy Shermans at ranges where return fire was useless. On paper, German engineering won. On battlefields, German engineering drowned under waves of American production. For every Panther destroyed, 3 more Shermans appeared. Math doesn't care about quality. When quantity reaches biblical proportions, the Soviet numbers add crucial context. The T-34, arguably the war's best tank design, saw roughly 84,000 units produced. Combined, American and Soviet tank production reached approximately 180,000 armored vehicles. Germany, Italy, and Japan together managed about 50,000. The Axis powers were fighting a 3-front war against an enemy, producing tanks at nearly 4 times their combined rate. German tank crews reported the psychological horror of destroying 5, 6, or 7 Shermans in a single engagement, feeling victorious, then watching 10 more crest the hill behind them. Tactical superiority became strategically meaningless when the enemy could afford losses you couldn't. Every Sherman built represented maybe 2 hours of American production capacity. Every Panther lost represented 2 weeks of German resources they'd never recover. The replacement rate advantage broke German armor doctrine completely. Panzer divisions in 1944 were designed around the idea that superior tanks handled by experienced crews could defeat numerically larger forces through tactical excellence. This worked in Poland, France, early Russia, when German tanks were newer, crews were better trained, and logistics could keep units supplied. But by late 1944, those assumptions collapsed. A Panzer division losing 30 tanks in battle might wait 3 months for replacements because German factories couldn't keep pace. An American armored division losing 50 Shermans would receive full replacements within 2 weeks, and sometimes in mere days. Units that should have been combat ineffective after heavy engagement were back at full strength before German intelligence even updated casualty reports. The Americans weren't winning through superior tactics. They were winning through industrial inevitability. The strategic bombing campaign's effect on German production made the gap even more catastrophic. The Alcat factory in Berlin producing Stüge 3 assault guns got hit by B-17s in March 1944 and didn't return to full production for 4 months. The Henschel plant that built Tigers and Panzers was bombed 6 times between September 1943 and March 1944, each time causing weeks of delays. Meanwhile, American Sherman production never faced strategic bombing. It ran 3 shifts daily and had access to unlimited raw materials. Steel shortages never stopped Detroit. Aluminum was abundant. Rubber came from both natural and synthetic sources. After 1943, the resource disparity meant German factories were fighting to maintain output, while American factories were optimizing how fast they could build even more. The logistics tail Sherman production created was almost as important as the tanks themselves. Each Sherman required spare parts, ammunition, fuel, maintenance equipment. American factories didn't just build 49,234 tanks. They built the support infrastructure for 1,234 tanks. Spare transmission assemblies, replacement tracks, engine rebuilding kits, electrical components. The Red Ball Express supply routes in France after D-Day moved 12,000 tons of supplies daily, and significant portions were Sherman-related logistics. German units frequently abandoned repairable Panthers because they lacked spare parts or recovery vehicles. American maintenance battalions could rebuild a damaged Sherman using standardized parts from any factory, getting tanks back into action in 72 hours. The assembly line's emphasis on interchangeable parts meant the entire logistics system worked at assembly line efficiency too. The crews themselves became part of the quantity advantage. Training a Panzer crew took 6 months. By 1944, because Germany lacked fuel for extensive practice, experienced instructors were dying faster than they could be replaced, and every tank used for training was one less tank on the front. American tank training had Sherman mock-ups, unlimited ammunition for practice, dedicated training facilities far from combat, and most importantly, time. A crew could train for 4 months stateside, then reach Europe in a brand new Sherman that rolled off the line the week they shipped out. The industrial system didn't just produce tanks, it produced trained crews to match production rates. By 1945, the American armored force had become a self-sustaining system where production, training, logistics, and replacement all moved at the same relentless pace. Germany never had a chance against that kind of systematic dominance. The Shermans didn't need to be better, they just needed to keep coming. And they never stopped coming. William S. Knudsen died on April 27, 1948, in Detroit, in relative obscurity. No state funeral, no memorial on the National Mall. The New York Times gave him 4 paragraphs on page 23. Most Americans who'd driven Chevrolets or served in Sherman tanks had no idea who he was. This was the man who'd received a unique honor in American history. President Roosevelt commissioned him directly from civilian to lieutenant general in January 1942, the only person ever to skip every rank from private to 3-star general. He wore the uniform for 3 years, never commanded troops, never fired a shot, and did more to win World War II than most battlefield commanders. Eisenhower later said Knudsen's contribution was as critical as any general's. But history filed him under footnotes while celebrating tank commanders who drove the vehicles his system created. The assembly line doctrine Knudsen perfected didn't die with him. It materialized into every corner of military production. The B-24 Liberator bomber production at Willow Run used Sherman assembly principles, eventually producing one bomber per hour. The Liberty ship program built cargo vessels in 42 days using modular construction methods directly copied from tank production. Post-war, the Pentagon embedded civilian production experts into military procurement permanently. The concept of arsenal of democracy wasn't poetic language anymore. It was official doctrine. America would never again rely on slow military contractors hand-building weapons. Everything from aircraft carriers to artillery shells would be designed for mass production from day one. Wars would be won in factories before soldiers fired the first shot. The Cold War defense industry became Knudsen's ultimate legacy. When the Soviet Union became the new threat, American military planning centered on the production advantage. The M48 Patton tank, M113 armored personnel carrier, M16 rifle, all designed with manufacturability as a primary requirement, not an afterthought. Defense contractors had to prove they could produce weapons at scale, not just build superior prototypes. This philosophy reached its peak with the M1 Abrams tank in the 1980s. The Lima Army Tank Plant in Ohio, built directly on Sherman production principles, could produce 120 Abrams monthly, a 60-ton main battle tank rolling off the line every 6 hours. The numbers weren't Sherman level, but the philosophy was identical, overwhelmed through production capacity, not through marginal technical superiority. The civilian production model influenced more than military hardware. It changed how America thought about industrial mobilization. The 1950 Defense Production Act, still in effect today, gave the president authority to force private companies to prioritize government contracts during emergencies. Exactly what Knudsen did informally in 1941, the Strategic National Stockpile, FEMA's emergency response planning, even the COVID-19 vaccine production in 2020 to 2021, all used frameworks developed during the Sherman production crisis. The idea that civilian industry could be rapidly converted to emergency production, that private companies and government could partner at massive scale, that speed mattered more than perfection in crisis. These weren't natural assumptions. Knudsen proved them viable when most experts said they were impossible. But the doctrine had cost nobody wanted to discuss. The assembly line philosophy prioritized quantity so heavily that quality sometimes suffered fatally. Sherman crews paid the price in North Africa and Normandy, burning inside tanks that were good enough to produce quickly, but not good enough to protect them adequately. The institutional bias toward mass production meant the American military sometimes fielded inferior equipment simply because it could be built faster. The M14 rifle, M551 Sheridan tank, Bradley fighting vehicle, all products of a system that occasionally valued production speed over combat effectiveness. Knudsen's genius was recognizing when quantity mattered more than quality, but the system he created sometimes applied that logic even when quality should have won. The final assessment requires uncomfortable honesty. Knudsen's assembly line doctrine won World War II. There's no serious debate about that. The 49,534 Shermans, produced by workers who'd never built tanks before, delivered by a system that shouldn't have worked according to military tradition, crushed Axis armor through sheer, overwhelming presence. But those same Sherman tanks were objectively inferior to their German counterparts in armor, firepower, and crew survivability. American tankers died in greater numbers because the production system prioritized getting adequate tanks to the battlefield over developing perfect tanks for later. Was that the right choice? History says yes, the Allies won. But the men who burned in Ronsons might have wanted the conversation to be more complicated. Knudsen built the machine that won the war. Whether he built the right machine is a question that still doesn't have a comfortable answer. What's certain is that no other civilian in American history wielded more influence over military victory while remaining virtually unknown. The Danish immigrant who promised the impossible delivered exactly that, then disappeared into the footnotes while the world he'd helped save forgot his name. That might be the most American story of the entire war.